Okay, hi. This is part 4 of chapter 2. We are going to discuss scatter plots, correlation, and regression. For the key concept, this section introduces the analysis of paired sample data. In part 1 of this section, we discuss correlation and the role of a graph called a scatter plot. Just to make it clear, hindi pa tayo magko-compute dito. We are going to introduce the formula for finding the correlation R sa mga later na chapter pa. In part 2, we provide an introduction to the use of the linear correlation coefficient. In part 3, we provide a very brief discussion of linear regression, which involves the equation and graph of the straight line that best fits the sample paired data. All of the principles discussed in this section are discussed more fully in chapter 10. O, di ba? Layo pa. Chapter 2 pa lang tayo. But this section serves as a quick introduction to some important concepts of correlation and regression. This section does not include details for executing manual calculations, as I've mentioned earlier, and those calculations are rarely done. Instructions for using technology to obtain results are included in Chapter 10. Yun ang maganda dito. Hindi tayo magmamano-mano as much as possible. We are going to use technology in arriving with certain values. So let's start with part 1, scatter plot and correlation. Our objective in this section is to explore whether there is a correlation or association between two variables. We begin with basic definitions. So, unang definition natin, a correlation exists between two variables when the values of one variable are somehow associated with the values of the other variable. So, kapag ka yung isang value ay affected by the other value, there exists a correlation between the two variables. A linear correlation exists between two variables when there is a correlation and the plotted points of paired data results in a pattern that can be approximated by the straight line. A scatter plot or scatter diagram is a plot of paired XY quantitative data with a horizontal x-axis and a vertical y-axis. The horizontal axis is used for the first variable x and the vertical axis is used for the second variable y. Para lang din tong yung ginagawa natin sa Cartesian coordinate plane, nagpa-plot tayo ng points. Pero dito, hindi natin dinedefine yung ibang quadrants. Mostly, nandun lang tayo sa quadrant 1, positive quotient. The presence of a correlation between two variables is not evidence that one of the variables causes the other. Nabanggit na natin to nung una, correlation does not imply causality or correlation does not imply causation. We might find a correlation between beer consumption and weight, but we cannot conclude from the statistical evidence that drinking beer has a direct effect on weight. So, meron silang correlation, pero hindi natin pwedeng i-point na, nagiinom kasi siya, kaya directly affected yung weight niya because of the drinking consumption or drinking pattern of the respondent. So a scatter plot can be very helpful in determining whether there is a correlation or relationship between the two variables. Issue is discussed at length when the topic of correlation is considered in section 10-1. Maghintay pa tayo hanggang sa chapter 10 before natin i-discuss ng deeper yung correlation. So, dito sa mga susunod na examples natin, given na dito yung correlation coefficient na R, mag-aano lang tayo, mag-i-interpret na lang tayo. So, correlation, waist and arm circumference. So, data set 1, body data, in Appendix B, includes waist circumference in centimeters and arm circumference in centimeters of randomly selected adult subjects. Figure 2-14 is a scatter plot of the paired waist and arm measurements. Hindi ko na ipapakita kung ano yung table ng values natin dito. Ay papakita na lang natin yung figure nung mga plotted points for each dataset. So the points show a pattern of increasing values from left to right. This pattern suggests that there is a correlation or relationship between waist circumference and arm circumference. So ito siya. This is the waist circumference in centimeters, and then this is the arm circumference. As you will see from our scatter plot, papataas siya. So, kapag ka maliit yung waist, maliit din yung arm. Tapos habang lumalaki yung waist circumference, tumataas din yung arm circumference ng mga respondents. Tapos yan, may isa tayo naligaw dito na sobrang malaki yung waist niya. Tapos malaki na rin yung arm niya. And if you are going to draw a line that will fit this scatter plot, makikita natin na papataas yung slope. Ayan. Pwede tayo mag-drawing ng line dito. So, correlation. The distinct pattern of the plotted point suggests that there is a correlation between waist circumference and arm circumference. So, by visual analysis, titingnan lang natin yung graph, parang may relationship. Habang tumataas yung waist, tumataas din yung arm circumference. Now, let's go to example number 2. So, ito yung figure niya. So, this is an example of no correlation. This is for the weight and pulse rate. Again, meron tayong dataset 1 body data in Appendix B of your book. Bibigay ko pala yung copy nitong book na to mamaya. Kasi ang binigay ko sa inyo portion lang nito, 'di ba? But if you want to study in advance, sige, bibigay ko yung copy nitong book na to. Just don't distribute it, please. Balik tayo. In Appendix B includes weights in kilograms and pulse rates, beats per minute of randomly selected adult subjects. So figure 2-15 is a scatter plot of paired weight pulse rate measurements. The points in figure 2-15 do not show any obvious pattern, and this lack of pattern suggests that there is no correlation or relationship between the weights and pulse rate. So dito kalat siya. Isa lang siyang malaking plot, isa lang siyang malaking quadrant na randomly nakaplot yung points, pero wala siyang pattern na sinusundan. Hindi katulad nito, napapataas yung pattern na sinusundan niya. Pwede ka mag-drawing ng line that will fit the pattern. Dito, wala. Isang blot lang siya dyan. Parang isinabog mo lang na beads. Wala siyang pattern. So this is an example of no correlation dataset. The plotted points do not show a distinct pattern, so it appears that there is no correlation between the weights and pulse rates. Now we have example number 3. There are clusters and a gap. So consider the scatter plot in figure 2-16. So meron tayong dalawang cluster, tapos meron tayong gap. Merong mga ilang parts sa weight na walang kahit isang point or data point. It depicts paired data consisting of the weight in grams and year of manufacture for each of 72 pennies. If you want to check, 72 lahat yung mga period na yan. This scatter plot shows two very distinct clusters separated by a gap, which can be explained by the inclusion of two different populations. Pre-183 pennies, or 97% copper, and 3% zinc, but post-1983 pennies are 2.5% copper and 97.5% zinc. If we ignore the characteristic of the clusters, we might incorrectly think that there is a relationship between the weight of the pennies and the year it was made. If we examine the two groups separately, we see that there does not appear to be a relationship between the weights of the pennies and the year they were produced. Kasi kung i-disregard natin yung date of production nila, pwedeng sabihin natin na, papababa siya. Meron siyang negative slope ng line. But if you are going to focus on the year, makikita natin na walang correlation na nag-exist. Kasi magkaibang population sila kinuha. So the preceding 3 examples involve making decisions about a correlation based on subjective judgments of scatter plots. But part 2 introduces the linear correlation coefficient as a measure that can help us make such decisions more objectively. Using paired data, we can calculate the value of the linear correlation coefficient R. Yun nga, sabi ko, meron tong value na kinukuha, number siya, correlation coefficient R. Tapos meron tayong interpretation for each interval. Pero hindi tayo magko-compute muna. Sa mga susunod na example natin, given yung value ng R, i-interpret lang natin siya. So definition, the linear correlation coefficient is denoted by R and it measures the strength of linear association between two variables. The value of a linear coefficient R can be manually computed by applying some formulas that will be presented to you on chapter 10. But in practice, R is almost always found by using statistics software or a suitable calculator. Kung meron kayong calculator na Casio 991ES, doon ako pinakasanay eh. At saka yung mga sumunod doon, pwede nyong i-compute yung coefficient R instantly. Ano lang kayo, mag-i-input lang kayo ng data. So, using R for determining correlation. So, meron tayong dalawang type ng correlation. Actually, tatlo siya. Meron tayong negative na correlation. Pag negative yung computed value mo ng R. Tapos, meron tayong positive na correlation. Pag positive yung value mo ng R. Tapos, meron tayong, syempre, no correlation. Yun yung zero yung value ng R mo. So, the computed value of the linear correlation coefficient is always between -1 and 1. Pagka nakakuha kayo ng value na mas maliit sa -1, halimbawa -1.1, -2, tapos mas malaki sa 1, for example, 1.5, 5, 6, ibig sabihin mali yung computation nyo. So, if R is close to -1 or close to 1, there appears to be a correlation. But if R is close to 0, there does not appear to be a linear correlation. Meron tayo dito mga intervals na gagamitin as I've said earlier, pero ipepresent ko rin siya sa inyo later na pagka nasa ano na tayo, chapter 10. Kasi meron tayong tinatawag na weak correlation, weak negative correlation, negligible correlation, moderate positive correlation, moderate negative correlation, strong positive, strong negative correlation. So, may mga sinusunod tayong intervals doon. So, dito na lang muna tayo. For the data depicted in the scatter plot of figure 2-14, yung kanina natin na may positive na correlation, yung papataas, waist circumference and arm circumference, ang computed R niya is 0.802. Si 0.8, malapit na yan sa 1. And the data is the scatter plot on figure 2-15 result in R is equal to 0.08 or 8% lang. Pretty close to 0. These descriptions of close to -1 or 1 or 0 are vague. But there are other objective criteria. For now, we will use a table of special values in table 2-1 for deciding whether there is a linear correlation. So see the following example illustrating the interpretation of the linear correlation coefficient. So correlation between shoe print lengths and heights. So di ba ina-expect natin pag malaki yung paa, matangkad? So tingnan natin dito sa example natin. So consider the data in table 2-10. Ayan, meron tayong 1, 2, 3, 4, 5. 5 respondents. From the accompanying scatter plot of the paired data in table 2-1, it isn't very clear whether there is a linear correlation. Diba hindi mo alam kung pwede ba itong i-plot? Pwede ba itong i-fit sa isang line? Di ba hindi tayo masyadong sure. So, using statistical software, ang ginamit dito ay StatDisk. It was found out that the correlation coefficient is 0.591 or about 0.6. Ayan. Pakitandaan ito ha. Ay, ito. Yan. 0.5912691. Okay. So, in example 4, we know that StatDisk display that in using the 5 pairs of data from table 2-1, the linear correlation coefficient is computed to be 0.591 or 0.6. So, using table 2-11 to interpret R. So, consider the critical values from table 2-11 as being both positive and negative numbers. And draw a graph similar to figure 2-17. Use the values in the table for determining whether a value of a linear correlation coefficient R is close to 0 or close to -1 or close to 1 by applying the following criteria. Okay. Correlation. If the computed linear correlation R lies in the left or right tail region, beyond the table value for that tail, conclude that there is sufficient evidence to support the claim of a linear correlation. Okay. So, meron tayo ditong number line. So, this is -1, this is 0, this is +1. So, if for no correlation, if the computed linear correlation coefficient R lies between the two critical values, conclude that there is not sufficient evidence to support the claim of a linear correlation. So, ang critical value natin dito, number of pairs of data n. Kung meron kang 5 pairs, ang critical value mo daw is 0.878. So, ito, on the left tail, this is -0.878. On the right tail, that is 0.878. So, ang sabi, if the computed linear correlation coefficient R lies in the left or right tail region beyond the table value for that tail, conclude that there is sufficient evidence to support the claim of the linear correlation. So, tingnan natin kung nasaan si 0.5912. Ito yung critical value natin, -0.878 sa left at positive 0.878 sa right. So, kapag ka ito ay nasa right, nung 0.878, may correlation. Pag nasa left siya ng -0.878, may correlation din. Pag dito, negative ang correlation. Pag dito, positive ang correlation. So, nasaan si 0.591? Nandun lang siya sa loob. So, wala tayong correlation. Since maliit yung pair ng data mo, ang gagamitin mo lang ay 0.878. So, medyo malawak yung interval ng no correlation. Dun siya pumasok. Ayan. So, in figure 2-17, it shows that the linear correlation coefficient of R 0.591 computed from the paired sample data is a value that lies between the critical values. So, ito siya. It shows that we can consider the value R 0.591 to be close to 0. So, di ba nga kanina i-analyze natin kung close to 0 siya, no correlation, kung close to 1, with correlation. It is close to 0 instead of being close to -1 or +1. So, please take note na hindi natin tinitingnan basta-basta lang yung value, ha? Kasi baka sabihin nyo, 0.6. Ang layo kaya ng 0.6 sa 0. Mas malapit kaya siya sa 1. Kasi ano lang, 0.4 lang yung layo niya. Hindi po ganon. May tinitingnan po tayo na table. May tinitingnan po tayo na critical value para sa R. Meron tayong mas malawak na table nito. Nasa appendix lang siya. So therefore, we do not have sufficient evidence to conclude that there is a linear correlation between shoe print lengths and heights of males. So hindi enough yung evidence natin para masabi na may association or may relationship yung haba ng paa sa tangkad. So next, we have p-values for determining linear correlation. So in example 4, we use the computed value for the linear correlation coefficient, which is 0.591, and compared it to the critical values of positive and negative 0.878 found in table 2-11. In the real world of statistics application, yung mga gantong klase ng table, obsolete na siya. Kasi ang ginagamit na natin ay p-value. So, sa section 10 ulit, there's a more common approach that is based on p-values instead of tables. So, the StatDisk display accompanying example 4 shows that p-value is 0.29369 or 0.294 when rounded. And p-values are first introduced in Chapter 8. Pero ito yung pinaka madaling rule for for p-values. Meron tayong mga alpha na tinatawag. May mga level of confidence tayo na tinatawag. Usually ang mga ginagamit natin is 90%, 95%, 99%. This corresponds to 10%, 5%, and 1%. In decimals, these are 0.10, 0.05, and 0.01. So if your p-value is below those values, then there is a significant relationship or significant difference. Depende dun sa context ng problem mo. Since nasa correlation tayo, there exists a significant relationship. If your p-value is less than any of those three. So dito, ang p-value na computed daw is 0.29369. Sulat ko nga siya dito. Ang mga common na ginagamit natin na pang-test ay 0. Ay, na naman niya sumulat. Huh? Okay, dito ko susulat. 0.01. This is for 99% ha. Kasi 1% yung remaining. And then we have 95%. Ang pang-test naman natin dito ay P na 0.05. And then for 90%, we have 0.10 or 0.1. Ayan, sila yan. So your computed p-value is 0.29. Ano yung kasunod ng 29 mo? 369. 369. So ito yung mga alpha natin. If your p-value is less than your alpha, kahit alin man dyan sa tatlo, okay lang. Dinedetermine lang kung saan siya mas maliit for the significance. So, pwede kasing highly significant siya, or significant lang, or weak yung significance, negligible yung significance. So, usually kapag ka dito siya, pag lower pa siya sa 0.01, yun, sobrang high nung significance, at saka sobrang reliable nung result mo. So, if p-value is less than your alpha, there is a correlation. Ito yung pinakang summary nito. Since obsolete na nga yung testing natin ng R. So, ito, usually, kapag ka nag-compute ka din sa mga statistical tools na ginagamit natin ngayon, instantly, ibibigay sa'yo yung p-value. Ano yung advantage of using the p-value? Kasi ito lang yung tatandaan mo, yung mga alpha mo lang. 'Di ba? Kapag ka R ang tinest mo for significance, dapat may cheat sheet ka. Dapat hawak mo yung kodigo mo ng table of values. Dapat meron kang yung ganito. Ayan. Dapat meron ka nito. Pero kung p-value lang yung titingnan mo, kahit wala kang kahit na anong hawak, kasi ang dali nitong tandaan. 99% is 0.01. If it is lower than 0.01, then it is highly significant. If it is lower than 0.05 or 0.1, then there is a significant correlation. Okay? Okay. So, sana clear sa inyo. If you have questions, please send me a message. Ay, ito pala, may nakalagay dito. Only a small p-value such as 0.05 or less suggests that the sample results are not likely to occur by chance when there is no linear correlation. So, a small p-value supports that there is a linear correlation between the two variables. Buksan na naman siya. Okay? And correlation between shoe print lengths and height. Ayan. So, meron tayong isa pang computation ulit. Pero mas marami na yung ginamit na respondent. So, di ba kanina 5 respondent lang? Ngayon, 40 respondents na. And nung pinlot siya, ito yung itsura. By visual analysis, mukhang may trend, di ba? Mukhang papataas siya. Habang humahaba yung paa, habang humahaba yung shoe print length, tumatangkad yung respondent. Okay? So, dito, ang mga computed value natin ay R, which is 0.813, and the p-value is 0.000, which is very small. It is lower than 0.05. It is even lower than 0.01. So, dito, confident na confident tayo to say that there exists a linear correlation between the two variables. Okay? Okay. Ngayon, move na tayo sa part 3. Yes, malapit na tayo matapos. So, for part 3, this is for regression. So, when do we conclude that there appears to be a linear correlation between two variables? For example, yun nasa 5 natin, yung 40 na ang respondents. We can find the equation of the straight line that best fits the sample data. If you still remember from your geometry, meron tayong slope ng line. Tapos ito, this is the slope-intercept form of linear equation. So, M is the slope, and B is the y-intercept. So, we can predict the value of the next data set using this equation. So, balikan natin ito. So, di ba dito, ang mahabang paa natin ay about 35 centimeters. And he is about 195 ang height. Pero paano kung dadagdagan natin yung respondents natin? Tapos yung respondent natin ay merong 40 centimeters na paa. Ano kaya yung magiging expectation natin dun sa height niya? So, possible yan using regression. Pwede tayo mag-predict ng values. And it works both ways. Pwede rin naman na dito, halimbawa wala tayong respondent na 20 centimeters lang ang paa. But what if may nag-exist na ganun tao? What can we expect about his height? So, pwede tayong mag-assume ng values or pwede tayong manghula ng possible na values. Most likely ay mag-fit dun sa respondent na i-insert natin. And also, pwede rin sa gitna. Di ba wala tayo ditong respondent na 34 centimeters lang ang paa? Kung meron, ano kaya yung height niya? So, dito. Given a collection of paired sample data, the regression line or line of best fit or least squares line is the straight line that best fits the scatter plot of the data. The specific criterion for the best fitting straight line is the least squares property described in section 10-2. Kasi talaga ang correlation at regression ay pang chapter 10 pa. Pero since we are talking about graphs and scatter plots, nadidiscuss na rin natin sila. So, ito yung counterpart nung y is equal to mx plus b natin. If m is the slope and b is the y-intercept, the regression equation is y hat. So, this inverted V here is read as hat, sombrero, H80. Y hat is equal to B sub 0 plus B sub 1x. So, ang slope natin dito ay si B sub 1. Tapos si B sub 0, ito yung y-intercept. Or ito yung expectation natin pag 0 yung value nung ating dependent variable. Halimbawa, 0 centimeters yung yung paa. Ano kaya yung i-expect natin for the height? Yun. So, ito yun. Section 10-2 gives a good reason for using the format y hat is equal to b sub 0 plus b sub 1x instead of the format y is equal to mx plus b. So this section also provides formulas that could be used to identify the values of the y-intercept b sub 0 and the slope b sub 1. But those values are usually found by using statistics software or a suitable calculator. Okay. Regression line. So example number 5 included a scatter plot of 40 pairs of shoe print lengths and heights from dataset 2, foot and height, in Appendix B. So figure 2-19, show on the next page, is the same scatter plot with the graph of the regression line included. So dito ay ibinigay na lang basta ang ating regression line, which is y is equal to 80.9 plus 3.22x. Ayan. So kapag ka i-drawing mo siya, ito yung best fitting line for our scatter plot. Okay? And this will be helpful in predicting the values for those data points that is not included in our set of samples. So note that the equation shows the y-intercept of 80.9 that does not appear on the vertical scale in the graph. So the leftmost vertical scale in figure 2-19 is not the actual y-axis that passes through 0 on the x-axis. If the graph were extended to the left, the regression line would intercept the actual y-axis at the height of 80.9 centimeters. So ito ay approximation lang. Hindi siya nag-start sa 0. But if we are going to extend this to the left, we can expect that y is equal to 80.9 cm. Okay, that will be it for scatter plot correlation and regression. Yan, may maingay sa labas. Again, pili tayo dito ng medyo madaling sagutan. Ito, maganda to. In exercise 9 to 12, the linear correlation coefficient R is provided. Use table 2.11 on page 71 to find the critical values of R based on a comparison of a linear correlation coefficient R. Ito ay isa-separate ko kasi magpa-practice na tayo eh. Yan, gawa ako dito ng isa pang sheet. Tapos, ikakopy ko yung table 2.11 at ikakopy ko rin yung mga problem natin na naandito. Patience, patience. So, this is table 2-11. Paste natin siya dyan. And then, mag-hand tool tayo. Hand tool. Gagawa tayo nung boundaries natin for correlation and no correlation. Aba, lampas ba ako? Ito. Sagutan natin si 9 at 10. Nangyari dito? Ba't ganito lang to? Nagahang ba? Ayan. So, magsasagot tayo. Gagawa tayo ng ng range dito kung kailan natin i-assume that there is a correlation at kung kailan hindi. Pero ito yung old method na sabi natin kaninang obsolete na. So, kahit obsolete na siya, i-apply pa rin natin. Then later on, mag-p-value naman tayo. Okay, using the data from exercise 5, brain volume and IQ, the linear correlation coefficient is R is equal to 0.127. So, balikan natin si exercise 5. Hindi ko pa siya nakikita. Hindi natin alam kung ilan ang sample niya. Ito, brain volume and IQ. How many samples do we have? 1, 2, 3, 4, 5. So, we have 5 samples. So, again, ang target natin ay ito. Yan, 0.878 on both sides. Okay, so let's graph our area for correlation and no correlation. So, gawa tayo ng linya. Siyempre, nasa gitna niya yung 0. Nasa left niya yung negative 1 at yung positive 1. Yan. Tapos, ang ating critical region ay 0.878. Both sides to. Isang positive at isang negative. So, nasaan si negative 0.878? Nandito siya. Yan. So, everything na papunta dito, ito yung may correlation. Tapos, positive naman, 0.878, nandito naman siya. 0.878. Yan. So, everything na nasa labas nito, ito naman ay yung may positive na correlation. Okay? Tapos, gawa tayo ng isa pang color. Yan. And everything na nandito sa loob nito, ito naman yung may no correlation. Okay. Ang ating R ay 0.127. So, nasaan si 0.127? Nandito siya. So, 0.127. Okay. So, what can we conclude about the linear correlation? So, ito ay isang example ng no linear correlation at all. Kasi nandito siya sa region na walang correlation. Okay? Now, dito tayo sa exercise 6, bare measurements. So, sa exercise 6 ay nandito, how many samples do we have? 1, 2, 3, 4, 5, 6, 7. We have 7. So, dito naman, ang magiging target naman na, ay, nabura. Ang magiging target naman natin ay ito. Yan, 0.754. O, di ba, lumiit siya. So, burahin ko lang to. Burahin ko sila. Yan. Palit tayo ng kulay. So, negative 0.754 at saka positive 0.754 naman yung critical regions natin. So, ang ating R ay 0.980. So, nasaan si 0.980? So, si 0.980 ay nandito. Ayan. Ito si 0.980. So, nasaan siya? Sa may negative correlation? Sa no correlation? O sa may positive correlation? So, nandito siya sa may positive correlation. So, there exists a positive linear correlation between the variables. Or, maging mas definite tayo, ano yung variables natin dito sa bare measurement na to? Ayun, chest and weight. There is a positive linear correlation between the chest and weight in inches and in pounds. Chest circumference and weight. Between the chest in inches and weight in, saan siya nasa sulat? Weight in pounds of the bears. Of the bears in the sample. Okay? Okay, so I hope it is clear. Hanap pa tayo ng iba. Ay, walang p-value eh. Ito pala, P-values. In exercise 13 to 16, write a statement that interprets the p-value and includes a conclusion about linear correlation. So using the data in exercise 5, the computed p-value is 0.839. So dictate ko na lang ha, since the p-value is significantly greater than 0.05, there is no significant evidence, or we don't have sufficient evidence to conclude that there is a linear correlation between the brain volume and the IQ of the respondents. Now for 14, our p-value is 0.000. So, since the p-value is sufficiently small, there is enough evidence to conclude that there exists a linear correlation between the chest in inches and weight in pounds of the bears in the sample. Okay? So that will conclude chapter 2. Oo. End na yun ng chapter 2. Next, we have... So, muna pumunta sa chapter 3. So, measures of center, measures of variation, and measures of relative standing and box plot. Hindi ko i-discuss na si measures of center kasi meron na naman tayong video lecture nito. So, yun na lang yung panoorin nila. And of course, pwede nyo naman tong basahin din. Measures of variation, meron akong sample video for finding the range, the coefficient of variation, and the standard deviation. But, we are going to cite some examples din dito sa baba. And ang maganda din sa video na binigay ko sa inyo beforehand, excuse me, pwede nyo gamitin na lang sa Excel in finding the values for the center and for the measure of variation. Tapos, relative standing and box plot. Yan. Didiscuss natin yan later on. Kasi wala pa akong video nito. Hindi ko to isinama before. So, thank you very much for listening. And next time ulit. Thank you. Bye!